Good morning, grade 7. Hope you are all doing well and being safe. This is Miss Pamela giving the physics course. Today we are going to start with a new chapter, chapter 6, and we are going to take section 1, temperature, thermal energy and heat. So please open your books on page 176 and follow up with me. First, we are going to talk about temperature. Recall that all matter is made up of tiny particles that are always moving. Therefore, all particles of matter have kinetic energy. So we already explained previously that everything that has mass is called matter and that all matter is made up of tiny particles that are always moving. We also explained that anything that is moving has an energy called kinetic energy, which is the energy related to motion. The faster particles move, the more kinetic energy they have. Of course, since one of the factors that kinetic energy depends on is velocity or speed, then the faster an object is moving, the higher its kinetic energy. So the faster the particles move inside matter, the more kinetic energy they have. Temperature is the measure of the average kinetic energy of the individual particles in matter. So particles in matter are always moving. The faster they move, the more kinetic energy they have. And the measure of the average kinetic energy of the individual particles in matter is called temperature. As you can see in the figure in front of you, if an object has high temperature, then the particles are moving fast. And if the object has low temperature, then the particles are moving slow. In the figure in front of you, you can see a cold drink to the left and a hot drink to the right. The cold drink has low temperature because the particles have a low average kinetic energy since they are moving slowly. And the hot drink has high temperature since the particles have high average kinetic energy since they are moving fast. Measuring temperature. Temperature is measured using a thermometer. A thermometer is a device that usually consists of a liquid, such as alcohol, sealed inside a narrow glass tube. Of course, most of us nowadays have digital thermometers, but some people say that the old-fashioned ones, like the one you see in the figure in front of you, are more accurate. So how does a thermometer work? When the tube is heated, so when the temperature gets higher, the particles of the liquid speed up and spread out so the particles take up more space or volume. You see the level of the liquid move up the tube, as you can see in the figure in front of you. Whenever the temperature gets higher, the particles inside the liquid that is inside the glass tube of the thermometer speed up and spread out, so they take up more space or volume. This is why their level rises in the tube. However, when the tube is cooled, so when the temperature gets lower, the particles of the liquid slow down and move closer to each other, so that they take up less volume. You see the level of the liquid move down in the tube, as you can see in the figure in front of you. Whenever the temperature gets lower, the particles slow down and get closer to each other, so they take up less volume or space, and the level of the liquid inside the glass tube of the thermometer goes down. A thermometer has numbers and units or a scale on it. When you read the scale on a thermometer, you read the temperature of the surrounding matter. Thermometers can have different scales, as you can see in the figure in front of you. This thermometer has two scales, the Celsius degrees and the Fahrenheit degrees. So, all thermometers must have numbers and units or a scale on them in order to allow us to read the temperature of the surrounding environment. Please now pause the video for 5 minutes and answer the reading checkpoint on page 177. The answer is that the liquid particles speed up and spread out, so the liquid takes up more volume. Now we are going to talk about temperature scales. We have 3 common scales for measuring temperature: the Fahrenheit scale, the Kelvin scale, and the Celsius scale. First, we are going to talk about the Fahrenheit scale. The Fahrenheit scale is the most common temperature scale in the United States, so it is mostly used in the United States. It is divided into degrees Fahrenheit, of course. The freezing point of water on this scale is 32 degrees Fahrenheit, and the boiling point of water on this scale is 212 degrees Fahrenheit. The second scale is the Celsius scale. The Celsius scale is the most common temperature scale in nearly all other countries, like Lebanon. It is divided into degrees Celsius, which are larger units than degrees Fahrenheit. The freezing point of water on the Celsius scale is 0 degrees Celsius, and the boiling point of water on the Celsius scale is 100 degrees Celsius. So the units of Celsius degrees are larger than the units of Fahrenheit degrees. This is why the freezing point of water is 0 degrees on the Celsius scale and it is 32 degrees on the Fahrenheit scale. The third and final scale that we are going to talk about is the Kelvin scale. Temperature scale commonly used in physical science. So the Kelvin scale is the temperature scale that is most commonly used in physical sciences. It is divided into units called kelvins. So you might have seen the scale in chemistry, since it is used in sciences. The Kelvin units have the same size as degrees on the Celsius scale. The freezing point of water is 273 kelvins, and the boiling point of water is 373 kelvins on this scale. In the figure in front of you, you can see 3 thermometers with 3 scales, the Fahrenheit scale, the Celsius scale, and the Kelvin scale. This figure also shows the freezing points of water and the boiling points of water on each scale. As we already stated, on the Fahrenheit scale, the freezing point of water is 32 degrees Fahrenheit. On the Celsius scale, it is 0 degrees, and on the Kelvin scale, it's 273 degrees. However, the boiling point of water on the Fahrenheit scale it is 212 degrees, on the Celsius scale it is 100 degrees, and on the Kelvin scale it is 373 degrees. You might have heard of something called the absolute zero. What is the absolute zero? The number 273 is special. Scientists have concluded from experiments that negative 273 degrees Celsius is the lowest temperature possible. No more thermal energy can be removed from matter at negative 273 degrees Celsius. So, no matter can have a temperature that is lower than negative 273 degrees Celsius. This is why the number 273 is special. 0 on the Kelvin scale represents negative 273 degrees Celsius, and this is called the absolute zero. So the absolute zero is 0 on the Kelvin scale and negative 273 degrees Celsius on the Celsius scale, and it is the lowest temperature possible. Now we are going to talk about converting units. In this lesson, we are going to learn how to change from Celsius into Fahrenheit degrees and from Fahrenheit into Celsius degrees. First, converting Celsius into Fahrenheit. So if you know the temperature in degrees Celsius and you want to find it out in degrees Fahrenheit, you use the equation that you see in front of you. Degrees Fahrenheit is equal to 9/5 times degrees Celsius plus 32. Of course, you do the multiplication and then the addition. In order to convert Fahrenheit into Celsius, so if you know the temperature in Fahrenheit degrees and you want to know it in Celsius degrees, you use the equation you see in front of you. Celsius degrees is equal to 5/9 into Fahrenheit degrees minus 32. Example, how much in degrees Celsius is 300 degrees Fahrenheit? So here you want to convert from Fahrenheit into Celsius degrees. So you use the equation that you see in front of you. Celsius degrees is equal to 5/9 into Fahrenheit degrees minus 32 equals 5/9 into 300 degrees Fahrenheit minus 32, which is equal to 148.889 degrees Celsius. So 300 degrees Fahrenheit is equal to 148.889 degrees Celsius. Please, as a homework, solve number 1, parts A, B, and C, and numbers 4 and 5, page 181. Convert 37 degrees Celsius, which is the normal body temperature, into degrees Fahrenheit. Your homework must be done and submitted to me on Tuesday, May 5. Thank you, good luck, and stay safe.